In this lecture, I will be going to explain this beautiful article, break it down, which is a very nice data set for question understanding. And so you can use it for semantic parsing, but it's a middle layer. So it's a different formalism, which is called QDMR, question decomposition meaning representation formalism, which is shown in the middle here. And the top is the annotated with natural language questions from multiple sources, because it could be an image, it could be a passage, it could be from a database. But then you do, in a middle layer, you do a question decomposition. For example, you say first objects, then color of the objects, then the number of one for each two. And so you see how meaningful it is. So because nowadays researchers have, especially in Allen Institute, they have created this data set with the motivation that nowadays we want to avoid complex. We want to avoid the complex formalisms like lambda calculus directly. I mean, we use them, but in a different layer. So just like software architecture that you have with different layers, here we have the same intuition, and our problem of semantic parsing, which is really hard, we decompose it into several layers. And here, for example, you can do it in just 2 or 3 layers. So the middle layer could be a meaningful, could be a question decomposition meaning representation. And I've used this data set and I've written an article about how to predict these things. For example, how to predict first select and then project and then group and then superlative. So if you read my article, we can predict that here is select, and after that, so it's a sequence, and then project, and then group, and then superlative. And so this is an amazing data set. So there are some operators in that. In my article, I called them semantic operators. What I mean by semantic operators are just these filter, project, aggregate, and there are many of them. There are about 13 operators, I guess. And so it has several levels. For example, if you use the QDMR high level, this is an example. For example, what office also held by a member of the main House of Representatives did James hold before he was president? So we first select and then we filter. For example, return offices that was held when he was president. And this is another example. We select home pages, return me the home pages of PVLDB. So when we say return me, it returns all home pages. So by doing select. And then, but we want to filter, for example, just PVLDB. So we are filtering that. So you see, it's like a tree, and it's a tree that shows the semantics of this sentence. And you can look at this like this tree. So of course, this is not in their paper, but you can think about it like this. First you select, then you filter by this, then you project by citation, and then aggregate. You aggregate, it means the total of that. And another example, so there are some pros and cons of course, this is another issue that I've explained in my paper. I don't use this because it's very hard to find these splitting. Annotating them is expensive. So I propose another solution. And they have also another data set, which is the logical forms of that. For example, return me homepages of PVLDB, and they represent it like this. But the QDMR is primarily inspired by SQL. However, while SQL, SQL is for just relational databases, and you can do SparkQL. SparkQL is for when you have graph database, like knowledge graphs and those things. You can use SparkQL. So all of these things are different ways that you can represent a natural language into a meaning representation. So we have very different formalism for meaning representation. As you know, we have, for example, abstract meaning representation, lambda calculus, and different ways. For example, discourse representation, structure, and like that. So this is the QDMR definition. And also this article is really interesting. We use pointers for QDMR. And so we break it down. The break it down data set is like breaking into some pieces. First you filter, then project, then you compare, and then group. And that's it.